Good evening, all. So we'll talk about Bayesian network in machine learning. And this is obviously a very important concept. And we would like to understand that how the Bayesian network can be useful while working with any specific scenario in machine learning. So generally, whenever we start working with Bayesian network, it's representing in the form of a particular graph, which is known as a directed acyclic graph, DAG. So if you see this particular example, we have considered three different instances, like say, for example, hungry, followed by that cooking and lunchtime. And we start finding out the relationship among various variables which is available in a given scenario. Say, for example, if it is lunchtime, so how this lunchtime is depending on having hungry or a person is actually cooking a particular food. So let's explore certain scenario with the help of Bayesian network. We will proceed further to understand that how we can represent the same thing using probabilistic concept. Like say, for example, whenever we are making use of joint probability or once you start finding a conditional probability. So this is how the given scenario can be represented. Say, for example, we would like to find out the probability of hungry, cooking and lunchtime all together. So that can be represented in the form of a joint probability distribution. So if you just have a look on this equation, so ultimately it consists of three different probability, and first two is representing a conditional probability. So this is what exactly is the relationship between joint probability distribution and conditional probability distribution, isn't it? So based on this particular problem, if we calculate the value of this particular probability, so ultimately it's a product of lunchtime where we have the value of hungry and cooking at the same point of time, the conditional probability of cooking provided the hungry value has already been given, and the probability of hungry. So this is what exactly we represent over here, that in any specific lunchtime, what exactly is the probability a person is cooking and giving that some other person is hungry at the same point of time. So this is how we can make use of joint probability as well as conditional probability in a Bayesian network, which is having a significant impact in machine learning models. So as I already told you that whenever you are considering various type of conditions, so in that particular aspect, using joint probability distribution, sometimes it's very expensive, it's sometimes very tedious. So at that particular point of time, we always try to make use of conditional probabilities, which is actually originated from the concept of Bayes theorem, which we have learned earlier. So let's have a look on some inference which is associated with a Bayesian network. So we have taken certain data, and this is how the instance is being represented with 0 to 4. And we have considered three most important attribute: hungry, lunchtime, and cooking. And we have considered all possible conditions over here, because if you look at instance number 0, this is how we have taken the value that hungry is true, lunchtime is false, and cooking is true. And in that way, we have considered all possibilities from a particular given data set. So if this type of situation has been given to you, we will make use of Bayesian network over here, and we will start finding out the probability of lunchtime, the conditional probability of lunchtime where hungry and cooking value has been given. At the same point of time, the probability of cooking, that is also a conditional probability of cooking where the value of hungry has already been given, and the probability of hungry. And finally, we will see the conditional probability table has been given in the following way for uh, lunchtime, for cooking, and probability of hungry. So this is what exactly we are getting the value of the conditional probability, as we have seen the values being represented over here. And finally, in that way, we can calculate the joint probability distribution in the following way. That what exactly is the probability of being hungry while not cooking and not being lunchtime. So both these conditions are false over here. And you see the value of the probability is 14.18%. So this is how, based on any specific scenario, we can effectively make use of joint probability distribution, which is actually based on the conditional probability distributions. And this is how we can get the value exploring a specific scenario using a Bayesian network. So there are various fields in real world we can make use of Bayesian networks, like say, for example, probability of getting a job for a specific resource where we have several parameters, like say, for example, the education level, work experience, drive. So there are various parameters we have used over here. And ultimately, our main aim is to find out what exactly is the probability of a candidate being hired by any specific organization. So this is one scenario which can be explored with the help of Bayesian network, and we can create a machine learning model to make certain predictions based on the available situation or any specific scenario. Okay, and ultimately we can represent that in the form of a matrix. We can start finding out the correlation among various variables which has been used over here and their respective score. As you have seen over here, we have considered different type of parameters, and ultimately we start finding out the distribution values and start exploring the correlations among the variables. So this is very useful whenever you are doing any machine learning project and making use of exploratory data analysis phase. We can directly apply the Bayesian network concepts we have learned so far. Okay, so now coming back to one of the most important thing which we should learn over here, like how we can start applying Bayesian network based on the available parameters, as we have already seen. And our main target is to find out the probability of a person being hired or not. And this can be represented in the form of a directed acyclic graph or DAG. You can have a look on this particular diagram. You will get an idea that how the attributes of the data set has been taken, and ultimately we can explore and we can make a specific Bayesian network using the idea of directed acyclic graph. So in a directed acyclic graph, we have different nodes and the edges connecting the nodes, and every edge is having a specific direction. So now moving to a very interesting part over here, which we would like to know, that's known as the Bayesian belief network. So that is also a kind of graphical representation. And here we explore different type of probabilistic relationship among various random variables we are considering. So one thing always we have to keep in mind that when we start working with BBN, that is Bayesian belief network, it's actually based on a specific condition. Like say, for example, we would like to find out the probability of an attribute where the parent has already been given. The parent value is true, and we would like to find out the probability of any specific attribute. So whenever we have a specific classifiers with no dependencies on that particular attribute, in that specific situation, we can start to make use of Bayesian belief network. Let's do one particular example to explore this idea that how BBN can be utilized in any specific scenario where it's required to make use of any machine learning model. So if we consider this example where we have taken an alarm, and here we are focusing on the triggering of alarm, which is depending on two specific conditions. One is due to burglary or due to fire. And whenever we are concerning about the triggering of alarms, based on this alarm, two specific calls can be made, which is represented by P1 and P2 respectively. So this is one of the scenario where effectively we can make use of Bayesian belief network. As we have seen that we have already created one directed acyclic graph, nodes and followed by the edges. And now we will explore that how the concept of probability we can make use in this particular example. So as I already told you the scenario, so basically here we have two specific nodes and there is triggering of alarm because of two specific situation, either burglary or earthquake. And based on the triggering of alarm, a particular person is going to give a call, and we have two instances over here. One is P1, another one is P2. But there are several subconditions being imposed over here. Say, for example, for P1, might be having a tendency to forget to call a particular person even after hearing the sound of the alarm. At the same point of time, P2, another person might be far away from that particular alarm, unable to hear the buzzer, and then making a call is obviously not that much effective as long as P1 and P2 are concerned. So whenever we are considering any real world situation, like what we have done over here, the idea of Bayesian belief network is having a very significant impact in the prediction of any machine learning model. So exclusively, we can make use of Bayesian belief network in various parts of the machine learning. So first, we can visualize the probability model for any specific domain. We can explore the specific scenario based on the factual data as well as corresponding evidences. And finally, we can determine the dependencies among several variables in a specific scenario which has been given. And based on that, we can have clarifications, estimations, even any decision making systems in machine learning. So it's completely depending on the concept of Bayesian belief network. Okay, so there are a lot of places we can make use of this BBN strategies, like whenever we start working with pre-processing of data or post-processing of data, start exploring the relationship among different variables, isn't it? The actual learning, and to find out a specific pattern also of any random variables, the idea of Bayesian belief network is quite significant in machine learning. Let's consider another example. In the similar way, we have considered another example. And in this example also, you might have seen that a burglary alarm has been installed to detect burglary. But at the same point of time, the alarm is also giving a response in a minor earthquake. And now we have considered one particular person called Harry, who's having two specific neighbors, David and Sophia, and it's a responsibility of this two-person. And whenever they hear any specific type of alarm, so it's a responsibility of this two-person, David and Sophia, to give a call to the owner, that's Harry. And ultimately, we will see that several subconditions also being imposed over here, that sometimes David is getting confused with the phone ring and the buzzer of the alarm. On the same time, sometimes Sophia is actually very busy in listening to the music and unable to hear that particular alarm. So this is one of the real world situation we have considered, and we'll see that how effectively we can make use of BBN to solve this particular type of problem. In this particular case, suppose my problem statement is to find out the probability of alarm has been triggered, but neither there is a burglary or an earthquake, but still a call has been made by David and Sophia. So this is one of the situation which has been given over here, and you are told to compute the probability, because this is how we explore different type of hidden observations in any machine learning model. Whenever we start training a machine learning model, this type of hidden features must be explored from a given data set or from a given scenario. And once you start finding out the solution, obviously, we will start adapting the features of the Bayesian belief network. We will start making use of a directed acyclic graph. And based on our idea, what exactly we have learned so far, first of all, we start finding out the necessary event which is associated with this particular scenario. Say, for example, burglary, earthquake, alarm, and the call made by David and Sophia. Once you have already identified the list of events in the network, we start finding out the probability. So we start finding out the joint probability of all those 5 events, as you have already seen. And finally, we make use of the conditional probability distribution, as you have seen this particular derivation. So ultimately, the value of the probability associated with this 5 event can be computed using the conditional probability approach, which we have already learned earlier, that how this joint probability distribution is actually depending on a conditional probability distribution, because it's much more convenient for us to compute the conditional probability, which is actually giving you the joint probability distribution value. So like that, we now plot the following directed acyclic graph where alarm is being taken. And we have also considered the nodes like burglary, earthquake, and the call made by David and Sophia. And it's represented with the help of a directed acyclic graph. And finally, we make use of computing the probability for both conditions being considered, true and false, for burglary, and the similar is for the corresponding earthquake. Now, here also we have created one truth table where we have this burglary and earthquake, and we have considered all possible conditions, and then we start finding out their probability. And based on that, now we can start finding out probability of making calls by David and Sophia respectively. And here also we have considered all possible conditions and start finding out the corresponding probability. So once you start finding out a solution using Bayesian belief network, this is what exactly we have represented the scenario of triggering of alarm, which is mainly due to burglary and sometimes because of the earthquake. And based on the trigger of alarm, what exactly is the probability of making calls made by David and Sophia respectively. So this is how, in a very explicit way, we can represent any specific scenario, a real world scenario, using Bayesian belief network. And this is giving us a very clear picture. And ultimately, we start finding out the probability with the following format. And based on this specific computation of the probability in all possible ways for the variables which has been considered in the scenario, ultimately, we got the conditional probability table for alarm A. So if you just have a look on it, we will understand that what exactly is the conditional probability of alarm A, which is depending on burglary and the earthquake. Similarly, we can also find out the conditional probability for David to make a specific call, where the call of David is actually depending on the probability of alarm. And we can also find out the conditional probability of Sophia to make a call, where it's also depending on its parent node, that is known as alarm. And finally, we got all the probability value based on a specific given scenario. So this is how we can make use of Bayesian belief network BBN in solving any specific type of real world scenario which has been given to us. And based on that, we can create a machine learning model. Thank you so much.